Are you frustrated that no commercial software can perfectly match your specific needs? The latest AI tools are powerful, but the subscription fee are just too high. Then this video is for you. Welcome back to the Ninja Robotics Education channel. We aim to break tech barriers so anyone can build, create, and innovate. Today, we are building exactly that, a fully automated local AI agent application. We are going to use Google's ADK, short for Agent Development Kit, which is a framework that gives you the building blocks for creating your own AI applications. And we are going to run the AI entirely on your own machine for free using Google's latest local AI model called Gemma 4. It is a powerful local model just released by Google, and is quite reliable compared with other local models I have ever tried. But of course, you can choose other LLM models you prefer, like DeepSeek or Llama. Why run it locally? Here are 3 reasons. First, privacy. Your data never leaves your laptop. Second, cost. It is 100% free and 0 subscription fees. Third, control. You can fully customize it for your personal needs. Today, I will guide you through building a native AI application from scratch. If you are a total beginner to programming, don't worry. I'm going to walk you through every single step. So, grab a coffee and let's get started. Before we write any code, let me show you what we are building. This is the ADK web interface, a browser-based chatbot that comes built right into Google ADK. So you can talk to and debug your agents visually. When I ask it to plan a 3-day trip in New York, my main AI, let's call it the big boss, instantly kicks off 5 separate specialist sub-agents in parallel. One researches the destination's history and culture, one checks the weather, one finds hotels, one looks up restaurants, and one finds tourist attractions. They all run at the same time, and then the big boss collects all their findings and writes a beautiful travel plan. Pretty awesome, right? To get here, you are going to learn 4 things today. First, how to set up your local AI environment using Ollama and Gemma 4. Second, how to get Google's API keys. This is your secret access codes to Google service, so your AI can search the live internet. Third, how to build a multi-agent pipeline using Google ADK's sequential, parallel, and LLM agent types. Fourth, how to use the ADK web tool to inspect your agents' thinking when they inevitably get confused. Let's get everything installed. In this tutorial, I'm using Visual Studio Code. It is also a free coding tool, but any text editor works fine. First, a quick note on Python. Python is the programming language we are using. You need version 3.10 or above. The MCP server tools, which is the short for Model Context Protocol, the system that lets your AI connect to external tools like Google Map. MCP does not work on older version. You can check your version by typing Python 3-version in your terminal. If it's too old on a Mac, you can update with brew install Python at 3.12. Now we need Node.js. This is a separate software package that allows us to run tools from the JavaScript ecosystem. Download the installer from nodejs.org. This gives us access to a command called npx, node package execute, which we will use to download and run our search and map tools on the fly without any manual installation. Now let's install Ollama. Ollama is the engine that downloads and runs AI model locally on your machine. You can go to ollama.com and download the installer. Once Ollama is running, we need to download the Gemma 4 model. Specifically, we are using Gemma 4 E4B. The E4B label means it is a compressed and optimized version of the model, designed to run efficiently on a regular laptop with 8 GB or 16 GB of RAM, without melting your computer. To download it, simply open the Ollama's chat interface, select Gemma 4 E4B, and type hi. Now let's set up the coding environment. Navigate to your project folder in the terminal. We are going to use a tool called UV, which is a very fast Python package manager. To get the UV package manager running, just type this command in your terminal. First, we need to create a virtual environment. Think of this as a clean, isolated sandbox for your project so that installing packages here doesn't affect anything else on your computer. Simply type uv venv.adk_env-python 3.12. Then you can activate it by typing source.adk_env/bin/activate. Now install all the Python packages we need, including Google ADK, Light LLM, and Python multipart. Google ADK is the main framework, and Light LLM is a compatibility layer that lets ADK talk to local running Ollama models, and Python multipart is needed by the ADK web server. We simply type uv pip install Google ADK, Light LLM, Python multipart. Finally, create the folder for your agent. Let's name it Local Travel Agent. An AI running locally is smart, but it only knows things from its training data. It has no idea what the weather is today or which restaurant just opened last week. To fix that, we connected to the live internet using MCP, Model Context Protocol. Think of MCP as a universal adapter that gives your AI hands and eyes to use external tools. To let our AI search the web and use Google Maps, we need two separate API keys. For web search, we are going to use Tably, a search API built specifically for AI agents. The great news is that it has a gorgeous free tier, 1,000 searches per month, with no credit card required. Here is what you need to do for Tably. Go to app.tably.com and sign up with your email. Then your API key appears on the dashboard right away. It starts with something like TVLY-. Copy it. This is your Tably API key. For Google Maps, we do need a Google Cloud API key. So go to console.cloudgoogle.com. This is Google's Cloud Control Panel. Then create new project. And go to APIs and Services. Then Library, and enable the Places API and the Directions API. Then go to Credentials and create an API key. Copy it. This is your Google API key. Now you got two keys, one Tably key and one Google key. You are ready to go. Your final ADK agent folder structure should look like this on the screen. The first ADK folder is our main project root. And inside of it, we have two different folders. One, ADK_env. This is our virtual environment. And the second, local travel agent. This is our main agent folder. Inside of agents folder, we have three files. First, .env. This is where we save our secret API keys. And the second, init.py. This is an empty file that tells Python this folder is a module. Lastly, we have agent.py. This is the main file we programming our agents. One important note here, the empty file called init.py must exist. It is a Python convention. It signals that this folder contains runnable Python code. Let's start with the .env files. Paste your keys in the format as you can see on the screen. The Ollama API base tells ADK where your local Ollama service is running. Port 11434 is Ollama's default, and the other two are the API keys you just got. Next is where the magic happens. Create and open your agent.py, and let's walk through it. First, the imports. This is how we pull in tools and libraries. I will show my code on the screen, and don't worry, I will also put the source code in the description below, so you can just download it. Look into it. We import 3 agent types. LLM agent. This is a standard AI agent powered by a large language model. Then parallel agent, who runs multiple agents at the same time. And sequential agent. It runs agents one after the other in order. Here is something important that you won't see in most tutorials. Local models like Gemma are not perfect. Sometimes they hallucinate, which means they make up things or tools that don't exist, and then the whole application crashes. To prevent this, we add an error recovery callback. This is a function that the ADK calls automatically when something goes wrong with the tool. Instead of crashing, it sends the AI a polite message saying that tool doesn't exist. Please try again with the correct name. And here is our error callback function. This single function acts as a crash shield for the entire pipeline. Now we tell ADK which external tools to use. We created 2 tool sets, one for temporary search and one for Google Maps. Each one uses npx to download and run the relevant tool on demand. Here is our code. Now let's create our 5 worker agents. Each one is an LLM agent, an AI agent powered by our local Gemma model. Each has a very specific job and its own tools to use. Here we need to notice the 2 important things in each agent definition. First, output key. This is how the sub-agent saves its finding into shared memory called session state, so the final synthesis agent can read them all. Second, on-tool error callback. This is our safety net. Let's take the destination expert for example. The only tool it is allowed to use is temporary search, and we need to explicitly say that in the instruction to prevent it from guessing. Here is our code. Destination agent equals LLM agent. Name destination expert. Model Ollama/Gemma4 E4B. Instruction: you are a destination expert. Call the temporary search tool with a query about the destination's history and culture. Only use the temporary search tool. Do not invent tool names or new tool. Then tool equals search MCP. Output key equals destination info. Lastly, our error callback. We create 4 more agents in exactly the same way. Weather expert uses temporary search. Restaurant expert uses map search places. Attraction expert uses map search places. And also, hotel experts use maps search places. Here is where most tutorials get it wrong. You might think you just need one big boss agent to run everything, right? But there is a subtlety. A parallel agent is excellent at running things at the same time, but it cannot write a final summary. It's more like a project manager who coordinates a team, not a writer. So we need a 3-layer architecture for our agentic workflow. Layer 1, a real agent. It runs all 5 specialists simultaneously and stores each result under its own output key. Then layer 2, LLM agent, the synthesizer. It reads all 5 output keys from shared memory and writes the final travel plan. Lastly, we need a sequential agent. This is the root agent. It groups layer 1 and layer 2 together in the right order. Research first, then synthesis. ADK will automatically look for a variable called root agent. This is what it uses as the entry point for your application. Now let's run the web server from your parent ADK folder. This boots up a web interface. Open your browser and navigate to the URL shown in the terminal, usually something like localhost 8000. Select Local Travel Agent from the drop-down menu. Then type a prompt on the chat interface like, please plan a 3-day trip in Tokyo from next Monday to Wednesday. I will visit there from Osaka. Please also provide me with a detailed train and recommended hotel on the 15,000 yen budget per day. Things like this and hit send. Now look at the left panel. This is the execution trace, your X-ray vision into the AI's decision making. You can see each agent being activated, the exact tool calls they make, and the raw data that comes back. This kind of transparency is very rare. Most AI chatbots are a black box, but ADK, you see everything. Alright, there you have it. In about 20 minutes, you've gone from a blank screen to a running multi-agent AI system entirely on your own hardware. In this video, you learned first how to set up a local AI environment with Ollama and Gemma. Second, how to connect it to the live internet using the Model Context Protocol. Third, how to build a 3-layer agent architecture with Google ADK. And fourth, how to add a safety net so hallucination doesn't crash your whole pipeline. The beautiful thing about ADK is how modular it is. If you don't want a travel agent, don't worry, just swap the Google Maps tool for a current tool or a document reader. Change your instructions, and suddenly you have a completely different AI assistant running locally for free, customized exactly to your needs. If you are interested in going deeper with the ADK, I have put the link of Google's ADK course in the description below. If you found this video helpful, please hit the subscribe button, drop me a like, and let me know in the comments what kind of AI agent are you planning to build. I genuinely love hearing what tools people want to create for their daily lives. Thanks for watching, and I will see you in the next video.